Alive. Hello,
Yes.
everyone.
Hello. Has she
Go
started
ahead.
recording? I'm not seeing the live
We are live.
button.
We are
So
live. We
we are
are
live.
live. Yeah. So
Okay.
hello,
Another
everyone.
exciting
Okay.
session on our. Oh, we're lagging. Okay, go ahead, Amel.
Okay. Hello, everyone, and welcome to our new event, our workshop about artificial intelligence, machine learning, and deep tech. I'm glad to see you all here. I'm Amal Khairi, full stack developer from Algeria. Also part of the Jubix family, part of the marketing and sales team. Now let's go to Busua will present herself. Busua?
Hello. Hello, everyone. Welcome to another exciting edition of our weekly workshops here at Jubix. My name is Abusi Waliuma. I'm a front-end software engineer, but here at Jubix, I serve as the marketing team lead. Jubix has been a very transformational and impactful journey for me. I have grown professionally, worked with an amazing team, and acquired relevant skills along the way. I believe that Jubix is indeed the future of work, innovation, and leadership. Welcome to our rebrand of the Global Tech Sprint Leadership Program, GTLP, which currently 80% of the participants that we have acquired jobs and further MT members from Ghana who see we are making global impact. Partnerships in our agency area and commitment. Jubix is a trio of three main products, the GTLR, Jumeet, and Momo Code Game Over. The GTLRA leads with transparency and shared learning to provide the world with a diversified recruitment agency that advocates for inclusive change across all markets to shared financial equity across platforms. Our mission is to provide this service internationally, both within and outside schools and universities, in order to drive innovation, shared knowledge, and universities, and facilitate cross border leadership, therefore paving the way for a brighter and more interconnected future. Brace yourself to hear more of our exciting products. I would now like to hand over um, to I'd now like to hand over to Vladimir and his
Malo.
partner to share more of the Jubix main application.
Hello, Amel. Hello, Busiwan. Thank you so much for that kind of introduction, and thank you, Jobix, for this opportunity. Today, Malone and I we're going to talk about something that is on the mouth of everyone. Everyone is talking about this: artificial intelligence, machine learning, and deep learning. The majority of us is using these technologies right now, but we actually don't know much of how it works, of the intricacy of the processes. So today thanks to Jubix, we're going to talk about a little bit about artificial intelligence and machine learning. We're going to give a quick introduction, a history of this, the limitations, ethical issues that we have right now, and a few examples. If it gets We are trying to make this a little bit simple, not too much technical words, but if it gets too complicated, please ask. We have the comments there. Ask away. We're going to be here to help. Right now, it seems like Malum is unable to join, so I'm going to start. So let's go, shall we? Let's start first with the history of AI, how it started and in what moment we are right now. AI didn't start yesterday. It's not something that just started developing. It's with us since 1955, when it was coined by John McCarthy during a conference on the Dartmouth College. This era AI is focused on symbolic reasoning, problem solving, aiming to create machines that could mimic human intelligence. From on the 60s and the 50s and the 60s, researchers work on rule-based systems and symbolic representation of knowledge. During this time, the development of GPS or general problem solvers by Herbert Simpson and Alan Newell marked the progress in program problem solving through logical reasoning. During the 70s and part of the 80s, we we talk about the sunset of AI. We talk about the period of AI as we know. Due, due to high expectation and overpromising, we have some issues here also that hand by hand with some limitations in computer power because AI and machine learning is so resource intensive. We face a period that is called AI winter, even though so much was tried to be done, but limitations is there. Sometimes we have great ideas, but the technology is not there yet. During the 80s, we have a period that we call expert system. During this time, AI research focused on developing expert systems, which were rule-based systems designed to emulate human expertise. We are going to talk a little bit more about this later on, and you're going to understand why we say this. And it was done on specific domains. Machines during this time were not as powerful as today, where we could talk about any kind of domain, any kind of specific topics. During the 80s and the 90s is the rise of neural networks. Neural networks gained popularity as a machine learning technique inspired by the architecture, the structure of the human brain. Back propagation, this is a crucial algorithm for training neural networks, was introduced during this time. During late 90s and early in the millennium is the AI renaissance. The increased computational power and availability or large data sets led to the renewed interest in AI. We have more technology, we have more data, more resources. So machine learning techniques, including, for example, support vector machines that I'm going to talk about in a bit, or Bayesian networks, so advancement. And as you know, since the early of the millennium to now, the technology advance, and each year, each 2 years, we see the resources. We have so much resources now, so much power that there was a shift towards data-driven approaches because well, now we have data. So machine learning techniques became way more prevalent. Big data, improved algorithms, and powerful computing resources contribute to breakthroughs in natural language processing, computer vision, and other AI applications. And finally, the last decade to now, deep learning, which is a subset of machine learning, use neural networks with many layers, which we call deep neural networks, has driven remarkable progress in image recognition. That's why we can have face recognition, we can have speech recognition. I don't know if you remember, like 10 years ago, when you tried to talk to the machine, you couldn't because it was it couldn't recognize accents, it couldn't recognize certain words, it was really limited. Now it's amazing. If you buy your Alexa, if you talk with Siri, you're going to see mind blowing. It's like you're talking with the person. Now, what's AI? What is artificial intelligence? Is the theory and development of computers system that can perform tasks that we will require human intelligence, such as visual perception, speech recognition, even sometimes decision making. Or translation between languages. We can use radar information. We can use video information to help cars drive itself now. It's amazing what we can do nowadays. Now, what types of AI we have? We have three types of AI: artificial narrow intelligence, that is also called weak AI; artificial general intelligence, that is also called a strong AI; and artificial super intelligence, or super AI. I'm going to do a little bit of introduction about this, don't worry. So, weak AI focuses on one narrow task and cannot perform beyond its limitation. You say what's going to do, and it's going to do that. It targets a single subset of connect abilities and advances in that spectrum. For example, Siri is an example of narrow AI. It performs within an limited and predefined range of functions. If you ask for something else, it's not going to be able to do it. General AI, or strong AI, can understand and learn any intellectual task that a human can do. It allows a machine to apply knowledge and skills in different contexts. And super AI surpasses human intelligence and can perform any task better than a human. Like nowadays, play Go. Machines can play better than us Go. And a few years ago, it was said that it was impossible. The concept of artificial superintelligence sees AI evolve to be a kind to human sentiments and experiences, that it doesn't merely understand them, but also evokes emotions, needs, belief, desires on its own. Of course, its existence is still hypothetical. We just seen the movies. The thing about the Go is a path through there. Now, I'm going to talk about a little bit about machine learning. What is machine learning? What kind of categories we have? What's the processes? What algorithms we use? And the limitations of machine learning. It's amazing, but we have so many things to consider and limitations there. It doesn't mean that it cannot be used. It doesn't mean that it doesn't have an immense application. But every new technology, there are some subset of things that we worry about. So, first, what is machine learning? Well, machine learning is a branch of AI that enables computers to self-learn from training data, from training data, and is improved over time without being explicitly programmed. So, what does it mean? That we have data without data. There is no machine learning. We create an algorithm to create models. And how the models create? The machine tries to find patterns there. Have patterns, improve over time with more information, and we can have predictions. Every result that we get from machine learning is not really learning, it's a prediction of what we got. And this is one of the limitations that we're going to talk about in a bit. What is different between traditional programming and machine learning techniques? In traditional programming, I believe the majority of you know. If you don't, well, welcome. You're welcome. Engineer, a developer, writes a series of commands that is performed by the computer. We have an input, we have the commands, and we have an output. And everything we need to do, we have to specify what we're going to do. However, with machine learning, we don't do this. It's an automate process that enables the machines to get the data, to from the data get a model, and from that the machine take action without any more of human interaction. Everything based, as I said, on past observations or past actions if necessary. So now we're going to talk about this process. We say, you know what, the machine learns, we have this experience, it finds patterns, it gets prediction. What what this entitled, what is this really about. So let's talk about the process. This look like a very simple flow chart. It is, but behind this we have something that, well, we have something that's really, really important: iterative process. So remember these four keywords: iterative, data, model, and algorithm. These are keywords for machine learning. And now I'm going to tell you why. We start with raw data. Where we get the raw data? Using interactions, we get from comments, from likes, from information that we get, web scraping, any kind of data that you can think of without any kind of structure or order is raw data. But raw data, just raw data, gets get us nowhere, because we can have, for example, duplicated information. We can have, for example, uh, information missing. We can have the information on such a structure that is impossible to process by our learning algorithm. So what we do, we pre-process. We try to structure this information so it's not just doesn't just make possible to learn from this, but also makes it more efficient. We process the information, we create new data structures, we put it on a way that is faster to process. And this is really important. In a bit, I'm going to, when I talk about the limitations, you're going to understand why. This is an interactive action. We get the data, we improve the data, and we go on and so on until we go to through the criteria. You say, you know what, the data is how we need. From there, we start applying our own learning algorithm. I'm going to give you some examples in a bit. And from that, we start creating models. We don't create one model. We create two, three, four models that help us get the best possible prediction. And even when we try, we get, you know what, we have this model, this model, this model, this model. Through interactive action, we can select one and we use it for application. And we say, you know what, this is going to be a golden model. We're going to use this. The process doesn't end there, because your data is going to keep updating. You're going to get more and more and more data. So this process is continue updating, even though no human is doing anything here. Everything is automated. That's why we say that machine learning comes from experience. For the data that we have, we try to find patterns, we create models, and we have this model to be used on our application and get the data, the output that we want. So we have we know how the process goes, we know what's machine learning, but the machine learning have different categories on depending how we process information, how this process work. We have three different categories. We have supervised learning, we have unsupervised learning, and we have reinforced learning depending on how it goes. Supervised learning learns from, well, we create models. The models are trained using label data sets, which allows the models to learn and grow more accurate over time. It means that a human puts some metadata on our data set, so it's easier for the machine to classify this. It's faster for the machine to get models. It makes things simpler, of course, but as I said, we have to have this information more. We have to recognize that we have to recognize some patterns before that. We have to know that we might have this kind of results to be able to use this. That's why we have these labels. For example, we want to train our application to recognize picture of dogs, to recognize if this is a tail, if it's a cat. We are going to label the pictures that is in our data set, so it's easier for the machine should classify this, and even to know that this is a dog, because it can organize the data. You can create models, but the machine is going to say, you know what, this picture are the same, but it's not going to know what kind of information you have. So you have to label your information so you can have a result, which is completely different from unsupervised learning. Unsupervised learning is a program that looks for patterns in unlabeled data. It means that the computer, the program, this application is going to find the patterns. It's going to find the trends that we are not explicitly looking for. For example, we have data for online sales. We just have that. We don't know how we're going to organize. We don't know what we're looking for. We we put some learning algorithm there to try to classify this and find models. And this application is going to, for example, identify the type of client we have, even though we cannot initially classify clients because everything can be so different. We can we can group things without predefining patterns. And finally, we have reinforced learning that learns from feedback. We train machines not just from the data set, but also through trial and error. So we have a result, we have a feedback, and from the feedback we have a reward system. So we train models, for example, to play games, or train AVs that are autonomous vehicles to tell, for example, the machines, you know what, you this is a person, and you shouldn't go go through a person. You have to go to the side. You create reward system so this application, this model creation knows that this is the best decision we make, and continues doing and learns from that. So there is a feedback in there. I'm sorry to talk too much. I hope you can see this image. If you don't know, for example, what kind of machine learning category you're going to use, what kind of system you're going to use, I can share with you later on the chat this chart. You have a small chart flow of what kind of what what is appropriate for you. If you have, for example, uh, a data, you have cluster. You want to see if they're cluster. You want to see if there are patterns there. You don't know much about the data. You're going to use the most appropriate would be unsupervised learning. In case you want to learn from action, you know there are some patterns, you want to get those patterns from there, you're going to if we part from there, you first have to know, you have to decide if you're going to use an active system or a passive. Remember that we talk about reinforce learns from feedback through trial and error. So this is an active system. From there, we need to see we have enough data. First, we have data. If we don't have enough, or we don't have any data, there's no machine learning. Without data, there is no machine learning. So nothing can be done. If we have enough data and we know this is going to be an active system, we we should use reinforced learning. If this is a passive model, it's going to learn from the model, and there's not going to be any more feedback. We're going to specific categories to say, you know what, this is going to be the best model. Then we part from here. First, we have to decide if we have enough data. If we don't, there is no machine learning, as I said before. If there is, we should see if the information, if there is some actions that human is going to do before the machine learning starts, before everything starts. If we're going to add labels, then the most appropriate would be supervised. Or if we know the patterns already and we want to classify and predict according to that, we also use supervised. If there is not enough data, also forget about it. Without data, it's not possible for machine learning. And now, We have categories, we know how to work, but well, okay, we have the category, but what can I do with that? The categories that we talk about, we have different algorithms for each of those categories. I'm going to do a quick mention of some categories here. There, some algorithm. We have a lot. This is some just of the most used, most common. Some even are so simple that you may think, oh wait, I saw that on school, on high school, even on linear algebra. So this kind of algorithm is also used for machine learning. For example, linear regression. You have data and you plot it, and from the whole set of data, you predict the result. If you have X and Y, you have a lot of data, and now you want to know how what what you might get from that X value. You predict from that. That's linear regression. Logistic regression, for example, is more limited. You don't have an X and a Y, and you're going to get different Y, different results. No. What you try to predict is between two elements. Yes, no, positive, negative, black, red, existing, not existent. There is not a range. There is just two values. From all your set of data, you're going to try to predict if it's one or if it's zero, if it's positive or negative. We also have, for example, for text analysis, naive Bayes classifier. That is, this is used, for example, when you have a blog. When you use this to, so you don't tag yourself each post you're going to write. You can have this kind of algorithm and machine learning. So your application is going to go through the text, and it's going to predict what tag you should put from a preset, obviously, set of data, predetermined set of tags. You just get one. If you need more tags per each entry, you're going to use the support vector machines. With this, as I said, you get a, a set of results. What kind of tags you should use for your for your blog entry, for the newspaper article, and so on and so forth. We have also decision tree or random forest. Random forest is an extension of decision tree. You are going to get all that inform kind of categories that is going to include for this. You have a trunk, you have a main a main category, and you're going to divide from there. You have a book, and from there you can have this book is braille or is written. From there you can get language, and you get different information. You have different classifiers of information from this decision tree. The extension of random forest is that you start adding trees within the tree, so it gets a little bit more complicated. And finally, for my examples at least, we got k-means or knn, that is k nearest neighbors. With this kind of algorithm, you group them, you put a criteria on, you know what, everything that is within this range is going to be this kind. So in k-means, for example, you have a centroid, you have a circle, you have a centroid, and everything that is within that, when the centroid doesn't change anymore, is within one category. So you have one category of data, another category of data, depending on how this information is plotted. Whew, I know it's a lot. I know it's a lot. There is so many more. This is just the surface. We're just scratching the surface. As I said, this is just an introduction. There's something else we need to talk about, something that is really important, and is something that we all should talk about. Not just people that use machine learning, but everyone, because at the end, everyone is affected. The limitations. We have different range of limitation, from ethical to resources to quality and understanding. Your predictions from machine learning can have bias, can have some unintended outcomes. For example, depending of the kind of data you have, your predictions can be racist, can be violent, can be insulting. That depends on the kind of data you have. Can prefer some result instead of other. Depends on the kind of data you have. Other limitation that we have is limited data availability. If you want to, for example, predict sickness, predict if this picture is going to cause a sickness, or depending of of a group of person, you're going to get what kind of illness. This kind of data is limited because of, well, med, medical information is private. You cannot have, for example, much information about uh, natural catastrophes. You have limited data, or even getting the data can be expensive or can be really resource intensive. So this is a very important limitation to take into consideration with machine learning. Because as I said before, without information, without data, there is no machine learning. Explainability. Usually, users or even people that create the models, you have the input, you have your prediction, and that's it. You don't understand how it works. It's treated like a black box, and this is a limitation. You have to understand what's going on, because if you cannot explain something, you don't know. It's important also to understand that computational resources it's an important limitation with us, because machine learning is very resource intensive. If you follow the news this year and last year, you know how much resources ChatGPT uses in in partnership with NVIDIA to get all the information they have. How much they have to invest, to how much of super machines they have, how many super machines they have, just to get information that we need. We can improve this, improving our data structure, of course, but still, the bigger the data, the more the more precise our predictions, but the more resource intensive this is. It can be also underfeeding or underfeeding. What does it mean? That the forecast can be, if we don't have enough data, we cannot have a really good forecast, a really good prediction. Or if our information is too simplistic, or either. So this is another limitation. Lack of causality. We get the data, we get the result, but we don't know the underlying cause. Machine learning doesn't help you to understand how much causality there is, or if there is an absence of this. So this is a very important limitation to take into consideration. And now, the elephant in the room, ethical considerations. And as I said, these have implications to anyone. Your data might be used for machine learning application. Your picture might be used. We have privacy concerns. If a data is biased, who is going to be, for example, liable for this? If cause some kind of harm, who is liable? If, if for example, we have we create a text, we create a book from the data we have. Remember, we don't create, is prediction. We transform this information to get another. So at the end, we are using some sources. So at the end, who is the owner of this? How we say, you know what, we got information from this. If at the end we don't know exactly how this is handling, because at the end everything is worked from the model through so through a lot of interaction. So there are so many ethical consideration that we all should talk about. It's a conversation that we all should participate, because it involves everyone. Now, let's talk about something a little bit more complicated, a little more fun, shall we? Let's talk about deep learning. Deep learning is one of the methods that help us overcome the limitations of machine learning. This is because deep learning learn help us cause the learning to focus on the right features. We can, with little guide, we can focus on the right direction. We can help our application go the right way. Basically, basically, deep learning mimics the way our brain works. It learns from experience. So, deep learning is going to learn from the models that we create, is going to understand which features and variables is important, so we can predict, uh, we can better predict the outcome. So let me give you a small example. We have, for example, to recognize faces of different people. We have to recognize faces of different people. And how we define this, how we are going to do this, we define facial features. We have eye, we have nose, we have ears, we have different features that we specify to our application. And this is going to help our application perform better. It's going to help us classify our information better because at the end we use neural networks. This is a small, simple picture that shows us how this is going to work. Oh, sorry, let me show you something else. This show how it works, how the information gets processed. So with neural networks, we have different layers of nodes. We like the human brain. Each node, each neuron, and it gets from one to another and another until we have the output where, well, the output layer where we have the information. Nodes within each individual layer are connected to the adjacent layer, and so on until we get to the outputs. The network is said to be deeper based on the numbers of layers we have. A single neuron in the human brain receives thousands of signals from other neurons, and the signals traveling between each between different neurons until we get the information, the output that we need as humans. The same goes for artificial neural network. Signals travel from one node to another, and we assign weight as we work on trees, on weighted trees. And the heavier a node is, the more it exerts an effect on this transmission, on the transmitted information to this node on the next layer. And that's why at the end, deep learning, it's actually, well, actually all machine learning is statistical. We get information, and through each weighted connection, we see, okay, next layer, this information is going to be classified like this, and like this on. And each layer, we have different adjustments until we have the information at the end that we need. If it's too complicated, I understand. Sometimes, the first time I read this, it gave a headache. The first time I used it to create text prediction, it was like, what? But at the end, it becomes fun. It becomes mind blowing. So in here, we have an example or how it works. We have we have information, we get information, and we classify this information we get from different nodes, and from different features, and we assign weight from this. We say, you know what, if it has this, it's going to we're going to go through here or through here and through here and through here, and we go on and on to classify better information. So we have a forward propagation. It means that input data is fed into our network, and computations are performed layer by layer. Each layer we pass, more computation, more classification is done. On each layer, we each layer consists of different nodes and different connections. As I said before, that we have different weights and different biases. We the information classified according to this, and this process repeated through until we get to the final layer, to the output layer. Oh, sorry, it's a lot. I'm going to get some coffee. So we get a final information, a final result without adjusting. We can have probabilities of different results based on the repetition and the improvement of our data based on these neural networks, on these trees, weight trees. Yes, trees. Yeah. And well, we have we have also to calculate the loss we will have because when you forward information, when you pass from one node to another and from one layer to another, the the predicted at the end, the predicted output is compared to what you're expecting. Has any kind of of manufacturing, of you have one input, you expect something, and how far are you from this? The loss function measures the difference between these two, how efficient it is for to say in engineering terms. And we quantify with this how our model's performance is. Common loss functions that we use includes mean squared error for regression tools or cross entropy loss for classification task. The goal always, like any kind of system, in engineering or any kind of engineering system, is to minimize the loss, to be as efficient as we can. Because the more efficient we have, the better results we're getting. So our model works fine. We're close to the results that we're supposed to get. We have two kind of networks: single layer or multiple layer. A single layer perceptron is a linear model used for binary classification. It models a neuron, and it has an input. We have a weight on each road, on each connection, and this neuron computes, and we have an output. Multi-layers have connections of multiple single layers. An important thing to know, an important definition to know about is backward propagation. A few moments ago, I talked about forward path, forward propagation, but also we need to talk about this. Is is training is a training process where where we feed error rate through to our network or neural network to make it more accurate. In a backward propagation step, the gradient of the loss function with respect with which parameter that we put, weight and bias, is calculated. With this, we and using a chain rules of calculus. I hope you remember your calculus. And starting from layer and moving backwards to the network, we adjust our parameters, make it more efficient, trying to minimize the loss. This is an optimization algorithm. And we use, for example, a stochastic gradient descendant which is often used to update the weight and bias on our model, on our network. And this allowed our application, our model to learn and improve over time, which is amazing. And this process, as I told you before, remember when I told you, remember the keywords: interactive, interaction, it, yeah, interaction. This process is repeated multiple times until the model converges to a state, a criteria that we specify. When we think, you know what, we have minimized loss. Backward propagation is crucial for training neural networks, and it's a key component on many of our more complicated machine learning algorithms. For example, remember I talked to you about the forward propagation. Now I'm going to talk about this is the zoom a diagram of how it works. We have propagation, forward propagation, where the information based on the previous information, previous on how the bias is, on the weight of the connections. And the training goes when we get data, we compare with the true value and say, you know what, that lost too much. No, we cannot do this. So we use backward propagation. We find an algorithm to improve our loss, and we improve the weight that we have until we get the results that we want. Everything that I talked about before that sounded really complicated is this. We have the information from one node to another until we get the results. We get our prediction. Say, you know what? No, 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 it's not good enough. Because we're comparing to what we think, well, what we know we should get, and we train our model so we can get a better result, and so on until we get something that is within our criteria. And finally, I'm not going to talk about this, just for you guys to know. Here are some examples of models. We have CNNs that are convolutional network and neural networks. We have RNNs that are recurrent neural networks. We have generative adversarial networks that are GNNs, and so much more. Thank you so much, guys. Thank you so much, everyone. Thank you for listening to me. Thank you for bearing with me. I know there was a lot, but I hope I help you learn a little bit more about this amazing technology. And I hope that you, if you're not participating, you start participating on this conversation, because it's important. Every input is important. At the end, what we're doing is kind of machine learning. We need everyone input to have a better data. So at the end, we get a better result. Thank you, everyone. And thank you, Amel. And thank you, Bosiwa. We're back to you.
Hello, everyone. Sorry, Amel, you're muted.
Sorry. Yeah, I was saying that it was really amazing. I learned a lot from Vladimir today, and it was really very constructive. What do you think, Busua?
Amazing presentation. I learned a lot as well. Did I know that machine learning was so interesting? Yes. So if you have any questions, comments, you can post them in the chat and we will be able to respond. And in the meantime, we have a lovely group of panelists who have come to share with us their amazing knowledge and expertise.
Yeah.
And I will let them introduce themselves.
Okay, let's welcome our amazing guests.
So perhaps we could
Alpesh.
go with the ladies
Mhm.
first.
Yeah, okay. Erin, can you please present yourself?
Sure, I'll start. Hi, everyone. My name is Erin Lenahan. I am a learning experience design and L&D, learning and development leader. Over the course of my career, I've developed programs that have incorporated AI and machine learning to bring language learning content to nearly 1 million children around the world. In the past year, I've really focused on how AI trends, especially large language models, can enhance learning and prepare generations for a future that we can't even imagine. So I'm the founder and chief learning officer of Impact Learning Solutions, which is a strategy and consultancy firm that helps edtech and mid-sized corporations leverage AI in curriculum development and instructional content to make learning more personalized and accessible. So I call myself a pragmatic practitioner of learning. So I like to help make big ideas and big theories like AI and machine learning accessible and practical for everyone. Thank you. I'm happy to be here.
Amazing. Shobraj, can you please present yourself?
Sure. Hello, everyone. This is Shobraj Shakdupia. I'm a computer science engineer by profession, and I'm the founder of Abstrabit Technologies, which is a new age AI-powered software development company. We are based out of India. It's been a year that we founded the company, and we've already worked with clients from 7 different industries. And we boast ourselves of having a 96% client retention, by which I mean, no, once the companies start working with us, it's seldom that they leave us. And it's obviously for the good. Yeah, and we generally work with startups which require products to be developed or want to scale and enhance their current digital projects. So, yeah, that's briefly about me. Thank you. And it's really nice to connect with all of the panelists here.
Amazing.
Thank you.
Okay. Thank you. Francesca?
Hi, hello everyone. I'm Francesca Rosella, the co-founder and chief creative officer at Cute Circuit. And Cute Circuit, we do wearable technology. We've been doing this for a few years now. And basically, we create garments with microelectronics and smart fabrics that can do magical things. And some of these things are like, for example, clothing that can change color and transform. And others is like clothing that can connect people emotionally. So lately, we've been using like lots of AI and mixed with wearable technology and fashion to see how we can bring people even closer together. So everything we do is about human connectedness and just using technology to facilitate human interactions.
Really amazing. Yeah. Alpesh, can you please present yourself?
Hi, I'm Alpesh Doshi. I'm based in London, and I work in technology and AI. I've been working in industry for about 20 plus years. I'm going to show my age compared to all of you guys. I apologize. I run a technology company, a global virtual company. We're about 25 people globally. We work around helping companies understand and deliver data across the organizations. We work with startups in a venture studio. And one of our ventures is a Kendra Labs, which is a platform to help companies accelerate the use of data in their businesses without having to build it all.
Thank you. Thank you. Yusan, can you please present yourself?
Hi everyone, I'm Hussein Kimanuka. I'm a co-founder of Ubuntu AI. I've been into NLP, natural language processing research for more than 7 years. And we are a group of African, US, and UK researchers seeking to use AI to create a more democratic and equitable future. Uh, as we know, while machine learning can be a great value, giving away data for free can amount for exploitation. So we are combining generative justice in AI so that we can provide a solution to develop a training through a circular generative economy. So our products is basically implemented into arts and culture, and I'll be happy to share with you all our exciting products.
Really amazing. So before starting our questions, I was asking the simplest question ever about AI that everyone is talking about. I mean, do you think I already asked this question to the audience? Do you think that AI is surpassing human intelligence?
Should I have like so many, like usually I have like so many like questions about like AI, and it's like, is it going to be better than humans? And I think one of my like my vision for the future is that we're going more towards hybrid intelligence rather than just artificial intelligence. So I believe that there will be like human guidance and then also AI capability for analysis and data. So I think it should definitely be sort of a like merging these two
Yeah,
types of understanding, because obviously, I mean, as humans, everyone, the first fear is always like, oh, are we going to be replaced by artificial intelligence? Because it seems like it's passing the Turing test with like so easily, right? But still, I think it has a little way to go, as Vladimir was saying earlier, like towards artificial general intelligence and then artificial super intelligence. So we're still a little bit not like our AI overlords are not taking over like cats already did. And so I think that definitely we can guide this process.
exactly. I think
Yeah.
that AI excels in data analysis and problem solving, but creativity, I guess that we humans excel in this too. Uh, Aaron, do you have anything to add?
Yeah, I would say that definitely piggybacking on what Francesca said is, there are things that AI is obviously going to be able to do better than humans, quicker and more effectively and efficiently. And we really need to focus on what makes us humans, special, right? There's always going to be a human component, empathy, Amel, you said creativity, that I don't think can be replicated with AI. The thing that I've heard said, and I like this adage, is AI won't replace people. AI will replace people not using AI. And so, from my perspective, I think we need to teach people how to use AI, what AI is, what's its capabilities, what's its restraints. And that starts with helping adopt a new mindset, strengthen metacognitive skills like critical thinking, problem solving, creativity, and strategic thinking.
Exactly.
I'll add a little bit on that. Yeah, regardless of the hype and the fears, we should rest assured that the need for skilled personnel is not going to diminish. Just because generative AI and large language model are a hype and they can bring some fear, achieving artificial general intelligence can be challenging. There are a lot of limitations, technical limitations, research limitations which are there, and it will take time for us to reach a level whereby artificial general intelligence is achieved. But we still have the time now to learn to leverage machine learning and artificial intelligence. And frankly, taking up opportunity will only help us stay competitive.
Exactly.
I think it's like I was chatting the other day, speaking at a conference the other day, and like one of the questions usually is like, "Oh, are all our jobs going to disappear?" And one of my ideas is that jobs are transforming, and because like every generation is always worried what happens to jobs that exist today? Will they exist in 20 years from now? And this is a question that every generation has asked, and especially in increasingly quicker incremental steps, since technological advancements are just happening like much faster than they used to 100 years ago, for example. And so I think that we should embrace the fact that jobs are, rather than disappearing, transforming. So for example, even my job as a fashion wearable technology designer didn't exist 20 years ago. Matter of fact, I had to start my own company to create my job. So I think that people shouldn't fear AI, but if they can embrace it and harness it to their best advantage, so that we can transform our jobs, but our society as well, in a more positive outcome.
Yeah.
Yeah, that is actually a very good point when Francesca said that there were a lot of jobs which didn't exist 20 years ago. So obviously AI there are a lot of jobs which we can do easily with the help of AI, but then there are a lot of jobs which are being created as well as, because of AI in our lives. So that is actually a good point.
Exactly.
Yeah.
Alpesh, what do you have to
Yeah,
say
I
about
mean, I
the
think
subject?
I think I've been doing working in technology for a long time, and I think every stage of the maturity of technology in the last 20-25 years has always said it's going to replace lots of different things, and roles are going to disappear, etc. What I've seen more of is that people adapt to the emerging technologies and adapt their roles, and there's new roles emerging, and I think that's really what's more important. And if you're not in tech and you are studying, I've learned tech and I learn about AI, because you'll never be out of a job. Will AI take over the world? I think Usen's talking about artificial general intelligence. I think we're many years away from artificial general intelligence being intelligent. Are we ever going to have a scenario where we won't be needed? I think that's beyond my lifetime, maybe beyond your lifetimes too, to be honest. but I think our lives will get better, because we can use this technology to take away all the mundane tasks, even some of the loads of the intelligent tasks, reduce efficiencies, actually be more productive and more creative. I think that's really actually the opportunity to be more productive and more creative rather than less. So I think it's a positive thing, but as I'm sure some of you know, there are dangers, but I'm sure there's a question about that, and we can talk about some of that in a minute. But there you go.
Great. I don't know. I'm kind of curious, since you all used AI in high level, let's say. Can you highlight your recent breakthroughs or developments in AI and machine learning that you find particularly, let's say, promising or exciting?
I mean, one of the recent things, as everybody knows, generative AI is really taking hold. But what I've seen is, if you're talking about a medium or larger company, there's a lot of work to actually get it implemented in companies. It's not as simple as just creating a little chatbot and off you go. There's a lot of work to actually create system processes, technology, applications, models, training models, building governance, data governance, getting data together. All those things are part of that challenge. And most firms that I speak to every day are either not even started their journey or right at the beginning of the journey of leveraging new technologies like generative AI. And I think generative AI is definitely for the next few years, there's a lot of innovation that's going to happen and invention. I read lots of research papers every day. I read a couple of papers a day, and I can tell you the breadth of how large language models are evolving is phenomenal in almost every single area you can think of. And so that's probably the most exciting. I mean, that's why ChatGPT has gone crazy. That's why ChatGPT coming a year ago has created a huge amount of new innovation and new research branches just around generative AI. So I think that's probably the most exciting part of AI at the moment. But that doesn't take away from things like machine learning. That they're still needed. You still need machine learning, which then potentially feeds into large language models, for example. So I don't think it's either or, but I think learning about how different elements of AI. So the previous speaker was talking about all the different types of AI that exist. The reality is you're generally going to combine those different technologies with generative AI to build a solution or solve a problem. And I think that's, for me, is where the exciting stuff is. I've done, myself and my team have built computer vision models, we built statistical models and a whole bunch of other things. Generative AI is a whole new set of tools, which is a very different set of tools than the current technologies around AI. And I think combining those will definitely it is really, really exciting to see what's going to happen.
Amazing. Anyone want to add something about this question? Sam?
Yes, I would like to add about Alpesh. Alpesh has said about generative AI. Yeah, is in the current moment, and we have realized that people are mostly focusing on generative AI. The reason is the products which are developed using generative AI can be helpful to the current market and the society. So by grabbing that opportunity, all the small and the big companies are trying to integrate generative AI into their everyday tools and trying to be available into the marketplace. But we should not disregard that there are other types of deep learning techniques which are implemented in the background in order to achieve generative AI. So it's it's a trend, generative AI currently, but with time there will be other technology which will emerge, which will surpass even the generative AI trend. Like any technology, there is always one which trends, and with time, others will take over and go above what generative AI is doing currently. My guess is basically reinforcement learning, which is an active learning or an active research field, and it's through reinforcement learning that generative AI was successful. So uh, basically, there will be more than generative AI in the future.
I don't know if we should be excited or scared, but yeah, yeah, thank you. I don't know. Before switching into tech, I mean, I'm a mechanical engineer with long years of experience in teaching too, and using AI by students was our big fear. So really, I'm curious about how Erin used AI in teaching programs. I don't know, this again.
Yeah, that's a really good question. I would say specifically in the education field, from K-12 to higher ed, there's a lot of fear around AI and a lot of misconceptions. And so I've been looking at this challenge from a few different ways. One from the student-facing side. How can we get students to engage and adopt a mindset to use AI effectively, and not just to do the work for them, but have it be an assistant in learning to enhance learning, and also from the educator or the organization side. How can we create governance, rules, processes? Also a mindset as well to embrace sorry, these new technologies. Overall, I would say one of the biggest challenges in education, and this was identified by Dr. Bloom in 1984, was that personalized learning was the most effective way to learn. However, it's not scalable, it's not practical until now. And so one of the big challenges is looking at these technologies in the generative AI and machine learning, and how can we move away from these traditional instructional and educational mindsets and methods and into a new future, and really help prepare generations for a world that we can't even imagine. Like Francesca said, and I know, we are making up our own jobs right now, right? Industries are being created. When I'm on the cusp. I remember a time before the internet, and I remember, after internet. You couldn't imagine I couldn't imagine that I'd be on a screen with people all over the world talking about AI, even 2 years ago. So we have to be able to leverage AI, not to keep us stuck in our safe and traditional methods, but really be able to learn more, and how can we leverage it to solve the real problems. So honestly, I've been really just focusing on the first thing, which is just the mindset, and helping people release some fear and the misconceptions about this technology, and get them to see the practical application it can have, whether they're an organization, a school administrator, a teacher, or students. So.
Yeah. I don't know if
ChatGPT really helps with that, because you don't have to have a technical degree, right? A lot of us think like we have to have a computer science or technical degree, but ChatGPT makes this concept of AI so practical. And so it's been really powerful to see, and coaching people to see how it can be, just a practical help in their life. That's the first hurdle, right, of acceptance.
Exactly. Yeah. Hello.
Yeah,
I
think, as Erin mentioned, what I'm seeing is that there's so many different industries where it can apply. Education is one, but if you take any industry, the opportunity is to transform industries, transform the way you work, to transform the way you learn. I was talking to an education provider 2-3 weeks ago, and we were talking about use cases and models around how can you actually make learning a lot more personalized and a lot more tailored to that individual. Yes, you have courses which are tailored to a certain extent, but the reality is it's still fairly manual. You could transform education by providing completely tailored education, right down to the individual slide. Even you could do that to right down to the individual slide. And I think that really is one of the most interesting things about how AI is going to change stuff. That the way you build applications, where you do learning, the way you do customer service, the way you build software, as I'm sure if some of you are software developers, I get on my team, we're embedding into the software development lifecycle how to design a product all the way to how to build a product, software product in this case. And we're embedding into the whole development process. And that's very new. Very few companies are actually doing that yet. And I think that will, for example, from the way I see it, you could be able to build applications significantly more quickly. You can build software and applications and businesses significantly more quickly, and complex applications. You can build a website now very, very fast. You can do it in 2 minutes by just going to Wix. You literally press a few buttons in 2 minutes, 5 minutes, 10 minutes, you have a website. But to build applications today, software of any complexity, still takes quite a lot of time. With this kind of technology, you can build a customized application through the development lifecycle, tailored to you significantly more quickly. I could say anywhere between 30 and 50%, if not more, faster. And also, therefore, you need fewer people. And if you're building a website 20 years ago, you needed an army of people to build a website. Now you can press 2 buttons, get a WordPress website up and running in no time, and someone with a browser can just learn how to build and create a website for themselves. And I think with generative AI specifically, and with other things around it, you'll be able to do so many of these different things so much more quickly and more productively. And I think that's a transformational thing that will emerge in 2024, I think.
I would like to add a little bit about what Irene said about education. Currently, it's now possible to build generative AI-powered personalized for a specific task. And so in the field of AI, these systems are often discussed as agents, like you, you personalize a certain large language model so that it can be able to give you instruction based on what preferences you have. Now, in the field of education, I assume that if someone is being able to access knowledge through a certain agent that is able to understand you from A to Z, then you'll be able to acquire knowledge very fast and very quickly. So in terms of education, with the development of agent, I think education will be much more accessible, and it will be, the knowledge transferring will be easy. Now the problem which comes is about the privacy. Whenever you are training a model, it feed on the data you're providing. So if the model is going to be accessing your personal data and the user's data, that brings in the problem of privacy, and that's something we need to discuss more about, and how to control the training models so that they do not get access to harmful and fraudulent data which can harm the different agent which will be deployed in the future.
Great. Shobra, do you have anything to add about the subject?
Yep, I was just points really well. I think when learning, we would have more different people have different ways of processing activities. So I think with AI, example, for me, a classroom can participate in the conversation with fellow learners. Whereas if we talk about my husband, materials, he'll take his own time and understand the concept. AI-powered platforms could be the game changer. Is your behavior, they understand your learning paths and recommendations. So yeah.
Thank you. By the way, your voice was like a robot, so in the subject. Okay, I guess that you have, yeah, maybe you have LinkedIn open in another window. Okay. I'm also curious about AI and fashion. I mean, fashion. Wow, it's it's the I don't know. It's really exciting to me and all the ladies, I guess. But AI in fashion, I'm really curious to know more about it. I didn't think about it before. Can you please tell us about that, Francesca?
Yeah, so I think there are like two ways that we are using AI in fashion. On one side is like the creative process, so to speed up the development of a collection. Now, the majority of designers is just using generative AI, such as like Midjourney or DALI, you name it, it's like they're all there, and I think it's amazing because it just speeds up the development process, because designers, we always have hundreds of ideas and not enough time to test them all, so we can simply just generate ideas really quickly. And but I think that on one side it's really exciting, and on the other side, as I think Alpesh and Yusen were saying, is where does privacy and come into it, and what happens to users data. Because, for example, I noticed after using Midjourney for a while that the diffusion model had been trained on about 20 years of my work. And so there are actually websites where you can go and check. One is called Have I Been Trained? And you can just put your name or like name of your artwork and check if your images or whatever your name has been used to train the diffusion model, right? And so I discovered, wow, this Midjourney can do deep fakes of my garments really fast. How did you learn it? And basically, that learned it from me. So I think that there is on one side like artists that are getting really angry with generative AI companies saying, oh yeah, you got all my data to train your models, and I don't want my data to be used for training anymore. And on the other hand, I started thinking that perhaps the diffusion models are so capable of recognizing artworks that actually we as artists could harness AI to understand who's copying our artwork. So we could actually harness it and perhaps add a little bit of a blockchain sauce in there just to make sure that original creators are rewarded for their original ideas. So I think that there is always like for the jobs and fears related to that is like, well, as an artist, if my creativity can be replicated so easily, what's going to happen? And then on the other hand of the coin, it's like, well, wait a minute, perhaps it can be of help to me because actually the work gets copied anyway. At least we can find out who's copying it and get a little token or appreciation for this. And then the other way we're using it is not just the creativity, but it's also like the type of like if there are sensors in the garments that we create, then we have a little bit of AI combined with machine learning so that we know what the bodies of the people wearing these garments are doing. So it's sort of like it's a two-way development process. On one side is enhancing creativity. On the other side, we're actually using it to make the electronics and wearable technology part of the experience even more precise and more adaptable to the user's needs. And so I think it's just like a really interesting. But I think that one thing that is amazing with generative AI is that everybody can come up with really crazy design ideas for garments that are really like the uncanny valley of haute couture and anything else. But it makes life of a designer even more complicated at times because the ideas are so out there. So my ideas already start, let's say, out there on the 85% scale. With AI, it gets to 105. And then all of a sudden, I still have to make it real and create a real wearable garment out of it. And so it makes the whole development process even first very easy and then very complicated because one has to come up with new technologies just to make the idea concretize into a real garment. So I think it's kind of interesting. It's like really very helpful and then very crazy at the same time. But the best thing about it, I think, for all of us is that we can learn something new. So going back to education is not like how do you design a new chair, but it's like how do you design a new way of sitting somewhere and when you want to rest. And so we are learning how to ask better questions, which I think that's the main, most important thing of learning something new. So I think that's what AI can help us do.
Amazing, yeah, yeah. I mean, I tried Midjourney and Leonardo AI most, and the result was amazing. To paint tails, you know. Yeah, and I didn't expect this from artificial intelligence. Busua, Vladimir, do you have other questions for our guests? Because I'm so passionate about the subject that I can stop. So please help. I can't really. I have a lot of questions. I guess I should stop. Yeah, Vladimir, Busua.
I have a comment to say, just
Yes,
going with a comment that our guest here talk about. There was a few time ago, Samsung have this kind of issue like Francesca had, that their own developers were using AI to improve their own code, and they were using putting their code inside the AI to improve it to work faster. At the end, Samsung realized that all their information, all their proprietary information, got learned by the AI models. So it's something that at the end, especially when you try to develop new tools, new application, things that going to be cutting edge, something that we have to be careful about, because at the end we are giving away our own information, our own discoveries without even realizing. And when we do, it's too late. So we, as you guys been saying, we have to try to find a balance in that. To we don't have to be scared of AI, something amazing, but balance is important to know when to use it, how to use it. Education, especially, I can just talk about from the student point of view how amazing a tool is, but also how dangerous can be, because it's like giving a calculator to a kid before the kid learns how to sum, rest, integrate, differentiate. People are going to get used to that, to these tools, without first learning how to process, how to reason with the information that, as I said, it's an amazing tool that we should use, but we have to learn also when to use it, how to use it, because yeah, it can be or frustrating or dangerous or simply giving away the things that cost us so much to build.
I'm going to add a little bit on Vladimir comment. Yeah. So when builders customize their own large language models with action or knowledge, the builder should be able to choose if the user chats with if the user chat that have been inputted in the model can be used to improve and train their model. Now, these choices, which should be made by the builders upon the existence of privacy control, will render the process of building model a little bit spectacle, because we need to input data into the model while making sure that that model does not use the data and share it with other general models. So we should always include an option of opt the entire account of our data can be removed from the general model. Now, if the user accept that his own data can be used to the general model, then a system of generative justice should be implemented whereby we return the values to the owner of the data. That's a principle which has been implemented in biological ecosystem, whereby the value which are extracted are returned back to to the person who uh, who who was using the resources. Like just an example in farming, when someone is farming and you are using a farm, whenever you are growing your plants, and when after harvesting the farm, you will still use the extracted features from the farm so that they can help the soil to grow more other plants. So it's same thing should be applied into AI, whereby the wherever I'm putting as data, I should have a return back to the data that I've already inputted in the model. So that's basically generative justice in AI, which should be implemented. And then on the second point, developing a protecting mechanism for users is very important, because as models are growing, individual data will be found into the general models, and at the end of the day, it can always bias the general model. So it's always important to control that user privacy and the user data, and make sure that we develop better models which can have protection mechanism.
Usua?
Okay, thank you very much. Sorry, we're racing out of time. This session has just been so outstanding for me. I wish we had more time to just expound all these lovely concepts and ideas. Because your final contribution. Shobraj?
Yes, sorry, Buzwa, I couldn't hear you during what were the last lines that you spoke.
Okay, so I was explaining that previously your mic had a bit of a challenge and we couldn't hear you effectively, so we wanted to give you a chance to contribute again.
Yep. So thank you so much for the chance. But yeah, I think the session is really nice and helpful. What I would like to, I think we are at the end of the session. So I would just like to conclude by saying, that as users of AI, and most of us are actually users of AI, we should embrace the change and the future. It's really important to identify the difference between a passing trend and something and some transformation which is actually going to last. And we have to acknowledge that the shift is actually happening. If we don't do this, we would always be worried about the changes happening, and we should hop onto that trend. So firstly, identifying a true revolution is very important. And these are obviously rapidly evolving times, and you can't always anticipate or be prepared for everything, right? So that is why it helps us to have an open mind, be receptive and accepting of the changes that are happening. And we should obviously, see, even if you're using AI, or let's say if you're using chat gpt, like I think Erin mentioned, that you don't need to be a computer science engineer, but also to use it effectively you need some knowledge. Even for your personal use, when you're using chat gpt on a daily basis, you need to give proper prompts, you need to train it so that you're able to use it effectively for your purpose. So yeah, that was about using AI effectively.
Okay, thank you very much. So we've come to the end of our session. And as usual, we hold these sessions every week, twice a week on Tuesdays and Thursdays. As our panelists, we're inviting you, please, whenever you have free time, you're free to attend more of our sessions. We are also rewarding prizes and rewards next year when we launch Jubix. If you attend any of our sessions and you invite friends or colleagues to join our sessions, we look forward to having you, and thank you very much for your time and for coming through. We appreciate your efforts.
Sure. Thank you everyone.
Thanks,
Thank you.
everyone.
Okay.
Bye.
Bye.
Bye.